Good morning to everyone. Let us see about the slip power recovery systems of an induction motor. Instead of wasting that slip power, what is meant by slip? It is the difference between your synchronous speed minus your rotor speed. That is ns minus n. We can call that as a slip. So it is going to be the slip power is going to be wasted, that you are going to recover it, and we are going to use it as an converting into an useful power. So instead of wasting the slip power in the rotor circuit resistance, a better approach is to convert it into a AC line power and return it back to the line. The two types of converters provide this approach is static Kramer method and static Scherbius method. In static Kramer system, it allows only at subsynchronous speed, that is below the rated speed. And in your static Scherbius system, it allows both the operation above and below the synchronous speed. So it is used to control the speed of the slip ring induction motor. We all know that the induction motor we will have the squirrel cage and slip ring induction motor. In squirrel cage induction motor, we cannot able to change, or you can able to control the speed of an induction motor, since it is winded in that is it is short circuited at the end rings. So only it is possible in slip ring induction motor. So the speed control of the induction motor can be obtained either above or below the synchronous speed. Stator voltage control and rotor resistance control have poor efficiency at low speeds and suitable for limited applications. In order to improve the performance of the systems like efficiency and capacity of the drive, if the slip power of the slip ring induction motor can be returned to the supply system, thus the overall efficiency can be increased. So there are two methods, one is Kramer's and Scherbius. It is classified conventional and your static power drive system. Now we can see about the Kramer's slip power recovery system. This is used to control the speed of an induction motor below the rated speed. This can be obtained by either conventional method or by using a static devices. So conventional Kramer or improved Kramer and static Kramer. So this is a conventional Kramer systems. Here you are using a ordinary rotary converter, that is by not using your static devices, that we can call that as a conventional one. From the induction motor we are grasping the slip power and we are converted that into a DC, and it is sent to the DC motors and rotary converters, and we are again feeding back to a slip rings. So here that wasted slip power is being converted into a useful power, and here we can able to control your speed by using a slip ring induction motor. So we can, by using a slip rings, by either we are adding a resistance or by decreasing a resistance, we can able to control the speed of an induction motor. So this type consists of slip ring induction motor, DC motor, rotary converter. The slip ring of the slip ring induction motor is connected to the input of the rotary circuit. It converts the AC voltage into DC and fed to the DC motor. The DC motor shaft is connected with the shaft of the SRIM. This DC motor shaft is connected with the shaft of the slip ring induction motor. The speed of this is controlled by varying the field regulator of the DC motor. The field regulator is connected to a separate DC bus. This is also known as constant power control. In case if rotary converter is over excited, it will take leading current which compensate for the lagging current drawn by SR. Induction means we all know that it will have a lagging. So if you are going for that over excited means it will go for the leading current. Hence the power factor of the system can also be improved by this method. This type is only preferred 4000 kilowatt and above the power level. So this is the modified Kramer systems. By using on 3-phase rectifiers, we are going to convert that AC into a DC and we are going to feed it to the DC motor. From that we can able to control the speed of your motor. So with the thyristors, instead of your rectifiers, we are using as thyristors. So it is called as a 3-phase controlled rectifiers. So in this type, when you are using a thyristor, it is more advantageous. You can get your output as your ripple free, that is it is free from harmonics value. So in this system, the mechanical rotary converter is replaced by a 3-phase diode bridge, and this 3-phase diode bridge is also is fed to the input of the 3-phase diode. It converts AC into DC and its ripple is filtered by a series connected inductor. The filtered DC output is fed to the DC motor. The DC motor is connected with the shaft of the SRIM motor. From that we can control the speed. So here we are using instead of that we have using a diode is replaced by an SCR for high power application, so that the harmonics can easily be removed. So static type Kramer system. So this is the static types. Here you are using the same thing, that is your supply is given to your stator and your slip power is taken from the rotor and is given to the bridge rectifier. It converts an AC into a DC. The smoothing reactor is used there to filter all the unwanted DC present on the output, and it is set back to the inverter. The inverter which operates converts your DC supply into an AC supply, and again it is fed back into the transformer itself, so that the wasted slip power is recovered in this method. This system is very popular in large pump and fan drives when range of speed control is limited near but below synchronous speed. The drive system is efficient but power converter is very low. The system is also called as the constant torque drive. So the advantages is which is less than the input power to the stator, and it is quite simple and stable, and the power factor can be improved. So these are all the conventional Scherbius drive methods. Thank you.